May the peace and the mercy and blessing of Allah be upon you. I will present the same results that are part of my PhD work entitled Kinetics of Crystallization in Sodium Zinc Phosphate Glass DTA Study. At first, the planning of this presentation will be as follows. We will begin by preface, then experimental procedure, followed by results and discussion, and finally the main conclusion and references. Preface and objective. Phosphate glasses have several advantages over conventional silicate and borate glasses in the reason of their potential industrial applications as suitable materials for fabricating devices include linear and nonlinear component, laser materials, solid electrolytes, batteries, and catalysts. In the present investigation, DTA analysis was used in order to study the kinetics of crystallization phenomena of zinc phosphate glass. Experimental procedure. Glass used in this study has the following chemical composition: Na2ZnP2O7. It was prepared by mixing appropriate amount of high purity chemical powders ZnO and Na2CO3 and NH4H2PO4 is greater than or equal to 99.9. The mixture was progressively heated in platinum crucible at 573 Kelvin in order to remove both ammonia and water. After grinding, the powder were heated in 873 Kelvin during 24 hours in order to reach the complete departure of carbon dioxide. Then the mixture was melted at 1023 Kelvin for the total reaction. In this table, chemical composition. In this figure showed a DTA glass. We notice in this curve the appearance of the endothermic step as the first peak. Its heat flows into the sample and defined as the glass transition peak temperature. On the other hand, crystallization takes place accompanied by the evolution of heat of crystallization giving rise to an exothermic peak. The figure 2, it's clear that the temperature peak increased with increasing the heating rate, and the temperature was in the range of 692 to 731. It can be seen that for all heating rates, the exothermic peaks are shifted toward higher temperature for increasing heating rates. The temperature peaks at different heating rates were present in the table 2. In order to know the crystallized fraction X, we calculated the integrate area of the curve, which means the fraction transformed X. A sigmoid character was obtained, which means nucleation followed by growth and fall crystallization as a final stage. In order to calculate the activation energy for complete crystallization, we use Kissinger's equation. Figure 4 shows the Kissinger plot of zinc phosphate sodium glass. Z ampere yields a straight line. The slope gives the activation energy E of thermal relaxation and crystallization, which is equal to 100 25.59 kJ per moles. The value of the Avrami exponent N is determined from the shape of the crystallization exothermic and is related to peak temperature. Their values are shown in the table below. Matsushita and Kawakis have proposed modified form of the Kissinger equation as logarithm heating rate exponent and division peak temperature square equal minus m. Multiply the activation energy division ideal gas constant and peak temperature, where n is the Avrami parameter which indicates the crystallization mode, and m is a numerical factor which depends on the dimensionality of crystal growth. The values of n and m for various crystallization mechanisms obtained by Matsushita and al. M calculated to the slope of the curve these values, indicating that three-dimensional of crystals growth with bulk nucleation and interface in reaction from a constant number of nuclei. Finally, the main conclusion as follows. The crystallization peak temperature shifts to high temperature with increasing heating rate from 690 to 731 Kelvin. The crystallized fraction took somewhat shape, which means nucleation followed by growth and false crystallization as last stage. The crystallization activation energy of the Dampierre glass of the value of 125.59 kJ per moles. The morphological parameters N and M are close to 3, which indicate a bulk nucleation character of the crystallization and interface reaction from with a constant number of nuclei. Thank you for your attention.